Hello, welcome back. In this video we will be continuing from where we ended last, and now we will go to the next thing, which is preparation of a vector. Okay, so how will we prepare a vector? It is very simple. We require, now first of all, the first thing we should know is what is a vector. So this vector is a sort of like a transporter or a postman. Okay, it takes your cDNA, complementary DNA. Okay, it takes from here where it was produced. Okay, it takes from here, and it enables us to move it to the bacteria, because eventually we want this to go to the bacteria, right? So it can't go, it can't just go like that. We need a vector, and the vector for this case is a plasmid. We will see in other cases, like in the production of monoclonal antibodies, we will have vectors such as rats, but in this particular case the vector is this plasmid. Now why we use plasmid? Because the plasmids can directly join the bacteria. Now the first thing we have to do is to get the plasmid. Okay, and it's not easy to get the plasmid. We have to get the plasmid for bacteria by cutting the bacteria down by restriction enzymes. So we use restriction enzymes on the bacteria. Okay. No, we don't use it's not the restriction enzyme. There are some other enzymes that normally cut this bacteria down so that we can get this plasmid. So once we get this plasmid is something like circular, like this. Okay, so the first thing we have to do is we have to cut to get the sticky ends. So we have to erase some of these parts. We have to cut. So now we have the sticky ends, the same sticky ends we had in the other case. Now we have the sticky ends, the stop and start codon. So we have this, and we have our bacteria. Which was, say, this one. Okay, but then this one also had sticky ends. Okay, this one also had sticky ends. As we said, we used restriction enzyme to cut this down. Okay, so even here we had sticky ends. These blue sides are sticky ends. So now these sticky ends with these sticky ends, they join. Okay, because this can be start and this can be stop codon, so they sort of join. So this is how we make this our so-called we make our DNA, our complementary DNA, get in the plasmid. Okay, and this plasmid is a vector. So this plasmid moves the DNA, okay, to the bacteria. We'll come back to that. First of all, you have to know that the bacteria is cut, the plasmid is removed, and the plasmid is also cut, and the complementary the complementary DNA is attached to this plasmid. Now one thing you should know is the plasmid, this attachment does not take place just like that. We need a enzyme, and the enzyme is ligase enzyme. Okay, this links the nucleotide backbones. Okay, so we need a ligase enzyme. We should know that these two enzymes are very important to know: the restriction enzyme to break down, and the ligase enzyme to make. So ligase is like a maker, and the restriction enzyme is a breaker. So we break down this, and we get this linking nucleotide backbones. Okay, we break down this ligase. Then we come back to this one. The insulin DNA and plasmid DNA are mixed together with a ligase enzyme. Okay, so this together are mixed together with a ligase enzyme is the same thing we said. Then the sticky end bases form hydrogen bonds. Yeah, how this region forms hydrogen bonds. Okay, this region over here, this plus this will form hydrogen bonds, and they'll be attached to each other. Okay, hope that's clear. Then ligase joins DNA backbone, and a recombinant plasmid is produced. So the DNA plus the plasmid, the complementary DNA, okay, plus plasmid plasmid, we get this one, recombinant plasmid. Okay, so it's just another way to, this plasmid is already combined with another thing, which is a complementary DNA. So that's how we get our recombinant plasmid. Then this does not end over there. Okay, over here, before keeping this inside here, there must be a way to identify. Okay, we have to identify which among the plasmids were changed to recombinant plasmid. Okay, so there is this process of identification. Now actually this identification takes place after this one have already joined here. Okay, so this one gets introduced into the bacteria, and then when it's on the bacteria, that's when you need to identify. Now how will you identify? You have all this bacteria. Okay, you have all this bacteria. You have all this bacteria. You have all this bacteria. Now you have to identify which bacteria has transformed and which bacteria has not transformed. So this is the challenge part. Now this, at first, it was a very difficult task for the scientists, because to identify those small bacteria, to get them, it's very difficult, right? You need a good technique for that. So what they did is they took this recombinant. There are two processes. There are two methods. There's earlier method and there is a modern method. Okay, this you can use markers. Okay, or you can use markers. The normal photosynthesis, the light markers and all those, or you can use insulin resistant marking. Now this resistance marking, what you do is, this process is very different, so we may need another space to explain the marking process. Okay, so let's take this space over here and explain the marking place. So what happens during marking is actually very interesting. Or maybe I should just pause this video here. I will explain the marking in the next video, and then we will finish this topic, right? Because it's very interesting here and I don't want to mess it up with this. So for the time being, hold on, and thank you for listening.